Hi everyone, welcome to today's presentation. Today we are going to look at application of law of conservation of linear momentum in the question that follows. A block of wood of mass 4 kilograms is suspended from a tree by a long, light string. A bullet of mass 100 grams is fired with a velocity of 100 meters per second and embeds itself in the target. Then, Roman 1, at what velocity does the target begin to move after the impact? 2, how high does the target move? And finally, state the energy change on the impact up to the highest point. Now to the first part, at what velocity does the target begin to move after the impact? We have a block that is suspended as shown there, and then we have a bullet approaching it. The bullet hits it and embeds itself in it. The block and the bullet will move together to some height. So for this first part, we are asked at what velocity does the target begin to move after the impact. At this point, we are going to apply the law of conservation of linear momentum, of which we know that the total momentum before impact should be equal to the total momentum after impact. And before impact, we have got the bullet whose mass you can consider m1 times its velocity. So that is the momentum of the bullet before impact plus momentum of the block before impact. So let's call that m2 times its velocity before impact, u2. Then after impact, we have the block and the bullet fusing together. So we combine the masses. We have mass 1 plus mass 2, and then they move together at a common velocity. Let's call that v. So it is this v that we are asked in this question. At what velocity does the target begin to move after the impact? Well, the mass m1 of the bullet is 100 grams, and 100 grams, we have that in kilograms, 0.1. We'll have to multiply by the velocity before impact, and we are told that is 100 meters per second. So we multiply by 100. When it comes to the block, the mass of the block is 4 kilograms. We have to multiply that by its velocity, and the velocity is 0, because when it's suspended, it rests, it doesn't move. And then we equate that to the right hand side. We'll have mass of the bullet 0.1 plus mass of the block 4 times the velocity. Now working out the left hand side, this becomes 10 and this is 0. The right hand side becomes 4.1 v. Dividing both sides by 4.1, we realize that v becomes from my calculator, I'm able to get 2.439 meters per second. Next, how high does the target move? So in other words, we are asked to get the height. Let me draw that once again so that it helps in explaining. We are required to get this height from the same horizontal level. And so at this point, the velocity is maximum, and that means we consider the kinetic energy maximum. And at this point, it will stop before it begins its journey backwards. At that point, we say that the velocity is 0 and the height is maximum. When the height is maximum, potential energy is maximum. In other words, all the kinetic energies has been converted into potential energy. So from that, we can form an equation, the kinetic energy converted to potential energy. and kinetic energy is calculated as a half mv squared, while potential energy is calculated as force times distance, and force is the weight of the two, the block and the bullet, that is their total mass, times gravity, that is the weight, and then we multiply by the distance moved, which is h, mgh. And from here, because the two masses here are just the same thing, we can cancel them to make our work easier. Okay, so the left hand side we have a half v squared, and v is the common velocity which we already have here, 2.439, that is times 2.439 squared, and then we equate that to gh, and g is 10. We multiply by h, so h is equal to, dividing both sides by 10, we'll have 2.439 squared over 2 times 10, that is 20. From my working, the numerator becomes 5.949 and the denominator is 20, and that finally gives us 0.2974 meters. So that is the maximum height that they both attained after the impact. For Roman 3, state the energy changes on the impact up to the highest point. So on impact, we had kinetic energy converted into sound must have been produced. So we have sound, and besides the sound, after that we have kinetic energy, because after the impact both the block and the bullet began to move together. So we have the energy responsible for the motion, that is the kinetic energy, and that kinetic energy is all converted into potential energy when it gets to the maximum height. This is the energy transformation or energy changes that took place during the entire process. We have come to the end of the solution to this problem. Thank you for watching. See you in the next video.